Okay, welcome back. In this video, lecture 41, we are going to talk about the big surprise here, okay? The big surprise here is that we are going to talk about the spatial distribution in the context, the Python here, okay? So first, let's look at the objective, okay? So in this context, we are going to go to the Python notebook, okay? We are going to go to the Python notebook, and in the description, in the video description, I'm going to follow the link in case that you want to experiment around this course, okay? So the objectives are that we are going to simulate the normal distribution using the matplotlib, okay? Visualize the daily return and log return using the set index. Get sample moments from the daily return and log return and understand what happened to the set during this year, okay? So we start by importing, okay? Importing some packages first. Because this one, I think I have to import some file. Okay, so let's see. Okay, because here we're going to use the external file also. So it's gonna be here. Okay, but first let's look at some what I want to say. Some distribution first. Okay, so we define n as the number of sample n. We use np.random.random. So it's gonna be, let's say, finding the sampling from the normal distribution, okay, the standardized normal distribution. And we define the number of means, and we then plot the histogram here, okay. And then we are going to plot normal curves against it. So after we run this code, you can see that the blue one is a histogram, is from the sampling, and the orange one is the exact normal curve. So it is gonna be roughly similar to one another, right? Okay, so let's see if we use the set index from 2020. So what happens, okay? So first we import the pandas, because the pandas is, let's say, one of the fundamental packages in data mining, okay? In data cleaning and so on. But I've cleaned the data already, okay? So let's look at what happened with the file, okay? So we have index column is the date, so this column is the index, okay? But the column that we are interested in the set index, okay, is a set index. But we just don't want only the number of the set index, but we want the daily return, okay? So let's say some heavy trader of the set index who traded on set every day may be interested in this rather than the pure number, okay? So the first one is not a number because we do not have anything to take the difference, right? So the numbers start from the second and the third and so on. So it's like minus 1.6%, right? And then we plot the distribution. Is it normal? Kind of no, right? Not like that. So two things that we notice here is that first, we have the outlier. A lot of the outlier here. So this one is. So maybe the extreme events are very likely and not that rare. That's why we see there. And if another observation is that if we use this, it is very tight, very tight. So the spread that we could get from investing on the set index daily is gonna be not that much because most of the distribution line between minus 0.025 is like minus 0.5%. Up until 0.05 is 2.5% is roughly symmetric. Not that symmetric because mostly it's gonna lie in this, it's gonna be something like left skew, right? But roughly symmetric. Okay. Okay, let's see. Next, we have this one, okay? But here, we're going to plot the normal curve too. Okay, to plot the normal curve, we use the stats.norm.pdf here. Oh my God. Like what I have expected. It is tighter than is expected in the normal curve. Right? Okay. So this distribution is extremely, I would like to say, extremely far from the normal. So we cannot say that during this year, set return is expected to be the normally distribution. So if you invest on the set with a belief that is normally distribution, so you are in the trap, okay? After seeing these two parts, please pause the video and think about its mean, standard deviation, skewness, and curvature. So look at this curve. Can you guess what is the mean? So mean is the what? The first moment, right? The first moment is the mean. Mean. And let's say the variance. And how about the skewness? And how about the kurtosis? So for the normal E of x is 0, whereas it's 1. S of x is 0. Okay, but how about the set index? Set daily return. What do you think those will be? Okay, let's think about it. And I'm going to run the code to find out the answer. Okay? So you find the mean, okay, .std, because .skew, because these are the function that we use quite often, okay? So you use two standard deviation. So that means what? That means you are equally likely to gain or to lose from the set index. The standard deviation is very low, as we have seen. If we talk about the skewness and the kurtosis, skewness minus, as I have said, the negative, the adverse consequences is more likely than the lucky events. The lucky events 7.5%, right? But the adverse consequences go to minus 10%. Okay? But we still have some hope. Some hope that is it log normal? Maybe normal doesn't fit. How about log normal? What does it mean? So you construct this because what? Because from the formula, remember, you have what? Rate of return, right? So if we talk about the rate of return, it's gonna be what? Price t minus price t minus 1 over price of t minus 1, right? But if you talk about the log return is gonna be what? Logarithm of pt over pt minus 1. Or in other words, it is the log of the 1 plus the gross return. Okay, so we are going to use this formula in order to find out about the log return here. Okay, so let's see. Okay, they are pretty similar, so we could expect that could we get the same answer maybe. Okay, let's see. it still looks the same, right? Even though it's long return because the number are extremely small. If you plot with the curve, oh my god, it's the same picture that we have found before. Okay, and if we look about this one, okay, the mean 0, so you have 0.021, 11.06, roughly the same number. So the one thing that notice here is that even though the curve, okay, let me scroll this back, okay, so even though the curve is look like it's very tight, so you could expect that maybe the kurtosis less than 3, I guess, but kurtosis here is very high. Why? Because usually when we talk about the kurtosis high doesn't mean it's gonna be something like this, right? And this one is gonna be normal. Right? So there is a high kurtosis. Okay? But in this case, it's strange. It's strange in the normal sense, but it's not strange in the finance. Okay? Because in finance, usually you have it's something like this. It's gonna be what? Something like this. So this one, extreme events. Extreme event is very likely to occur. That explains why the kurtosis is very high. But look at the middle here. The middle stuff here, what does it mean? It means that, okay, let me use another color here. For this one, between the extreme event and most of the distribution, it's not likely. Okay? So, and this kind of picture, and that explains why, even though the graph is very tight, but why the kurtosis is very high. Okay. So another question that we want to explore is that, okay, does it have any difference between positive or negative? Because say that, okay, negative go to minus 10%, but the positive go to only 7.5%. Okay, let's see. So we use the filtering here, okay? We generate the positive and negative return data frame. And we run for the positive and run for the negative, okay? Look at this number. 0.01, similar, very similar, very similar, very similar. So look at the graph, you can say that it's gonna be a very slight difference between the positive one and the negative one. Okay, but not that much. Okay. In summary, bond returns and log returns are far from being normal. It has been zero, implying that on average, we could not expect to get profit from investing in assets. It has extremely low SD, implying that the luck is relatively low in sets. Okay, it has negative skewness, implying that there is higher chance of being broke from investment than getting lucky and reaping high returns. It has extremely high kurtosis, implying that the chance of extreme event is not that extreme at all. Look at what happens. Okay, let's see. We have to convert this into the date time because we are going to plot into the diagram. Okay, so this is a set index, and this is the daily return, and this is gonna be log return. So you could see something like the similar patterns, right? So because I have collected data for only this year, so it's gonna be January, Jan 2020. And from the recording, it's gonna be like the November, but not the end of the November, okay? So you could see that in the third month, okay, in the third month, the set index dropped, let's say plunged significantly, okay, plunged significantly, and slightly increased, okay, but not at the level of the January yet, okay. It dropped significantly, but it increased, but it increased, but it dropped, but it increased, but it dropped. So, and this is consistent with this kind of picture where the volatility is extremely crazy here, extremely crazy in March. So in the March, what happened? So in the March in Thailand is like the lockdown. The government announces the lockdown, okay, and that's one of the reasons why the investor confidence crashed, okay, and it is extremely volatility here, okay. So you can look at the daily term volatility as one factor, okay, to measure the volatility, but there is another factor, let's say, called the VIX index, and the VIX index is the implied volatility for the put option on S&P 500. Or shortly, we can say that the VIX index is a fear index. Okay, it's a fear index, and it is the index that if it increases, it means people fear more. Okay, so this shows similar pattern. So for March in USA is show similar kind of picture here. Okay, and let's explain why we find that extremely unlucky events happens around the COVID-19 here. Okay, and the log return shows similar pattern. So can you see the full picture of the Thai set index now? Okay, let's say before you jump into any investment, it's a good idea to conduct preliminary exploration of the data first to get the general overview of the asset you are interested in. However, this is still the first step. In order to conduct investment in stock market, we should drill down into the sectors and the companies that we believe have strong fundamentals, okay? In addition, models should be constructed in order to see what factors could explain stock market returns. However, all of these are beyond the scope of the probability theory, okay? And this wraps up the end of the chapter 5. And in the next lecture, we are going to go to chapter 6. So good luck.